Hello everybody. In our previous videos, we studied about finding the total surface area of a combination of solids. Now in this lesson, we will study about the volumes of a combination of solids. So welcome to the lesson. Before trying out this example, let us understand that the volume of the solid formed by joining two basic solids will actually be the sum of the volumes of the constituents, as we will see in this example. So let us look at this example. Shanta runs an industry in a shed which is in the shape of a cuboid surrounded by a half cylinder, as you can see in the figure. If the base of the shed is of dimension 7 meters times 15 meters and the height of the cuboid portion is 8 meters, find the volume of air that the shed can hold. Further, suppose the machinery in the shed occupies a total space of 300 meter cube and there are 20 workers, each of whom occupy about 0.08 meter cube space on an average. Then how much air is in the shed? You can take pi to be 22/7. So if we have to solve this, let's understand the volume of the air inside the shed when there are no people or machinery is given by the volume of air inside the cuboid and inside the half cylinder. Taken together, we will get the volume of the air in the whole figure. Now, we know that the length is 15 meters, breadth is 7 meters, and height of the cuboid is 8 meters. So we can easily find the volume of the cuboid. And coming to the half cylinder, we know that the height of the cylinder is 15 meters and the diameter of the cylinder is 7 meters. So now the total volume required will be the volume of the cuboid plus half the volume of the cylinder. So we need to work out now. So the total volume will be volume of the cuboid plus half the volume of the cylinder. What is the volume of the cuboid? It is length times width times height. So we know that it's 15 times 7 times 8 plus half of the volume of the cylinder. So half of, what is the formula to find the volume of a cylinder? It's pi r squared h. So we can write it down here. Volume of a cylinder is pi r squared h. So pi is 22/7. Radius is going to be 7/2 because the diameter is 7. Radius is half of that. So 7/2 times 7/2. And the height of the cylinder is 15. Now we just have to simplify this, which is going to be equal to, if you simplify, 1128.75 meter cube. So the volume of the air within this figure, this cuboid, is going to be 1128.75 meter cube. Next, we have to find out what is the total space occupied by the machinery. It's given by 300 meter cube. So what is the total space occupied by the machinery as given in the question? It's 300 meter cube. Now from this we can find out what is the total space occupied by workers. Now how many workers are there? There are 20 workers. Each worker is occupying a space of 0.08 meter cube. So 20 workers will occupy a space of how much? So it's going to be 20 times 0.08, and that's going to be 1.6 meter cube. So now we can find out the volume of air when there are machinery and workers. What will we do? We will take the total volume and subtract it from the volume of the machinery and the volume of the workers. So what will be the volume of air when there are machinery and workers? So the total volume of air is 1128.75. Minus it with the volume of the machinery, which is 300, plus the volume of the occupied by the workers is 1.60. So when you subtract them, the answer you get is 827.15 meter cube. So this is the volume of air occupied inside the figure when there are machinery and workers. So what we did was, we first found out the volume of air completely inside the solid, and then we found out the volume occupied by the machinery, and we found out the volume occupied by the workers, and then subtract the total volume minus the volume of machinery and the workers, and you get the answer. So pretty simple problem. The only thing is, you need to remember the formula of volume of a cylinder and the volume of a cuboid. All the variables were already given to us in the question. Let's try this. A juice seller was serving his customers using glasses as shown in the figure. The inner diameter of the cylindrical glass was 5 centimeters, but the bottom of the glass had a hemispherical raised portion which reduced the capacity of the glass. If the height of a glass was 10 centimeters, find the apparent capacity of the glass and its actual capacity. You can take the volume, the pi, to be 3.14. So we know what is the diameter, the inner diameter of the glass, which is 5 centimeters. And we know what is the height of the glass, which was 10 centimeters over here. Basically what we have to find out is, find the volume of the entire glass, then find the volume of the hemisphere, subtract the two, and you will get the actual capacity of the glass. So let's try that out first. So what is the apparent capacity of the glass? The glass is a cylinder. So what is the formula to find the volume of a cylinder? It's pi r squared h. Do we know how much is pi? It's 3.14. Do we know how much is the radius? The diameter is 5 centimeters, so the radius is going to be 2.5. So it's 2.5 times 2.5. And what is the height of the glass? It's 10. So now we can easily find out by calculating this, it's going to be 196.25 centimeter cube. So this is the volume of the glass, the apparent volume. Now we need to find out what is the volume of the hemisphere, so that we can subtract the volume of the glass minus that of the hemisphere to get the actual capacity of the glass. So what is the formula to find the volume of a hemisphere? You need to know it. It is 2 over 3 pi r cube. Now we can plug in the values. 2 over 3 times pi is 3.14 as suggested in the question. What is the radius? The radius of the hemisphere is same as the radius of the glass cylinder. So which is going to be again 2.5 times 2.5 times 2.5. And when you calculate that, it's going to be 32.71 centimeter cube. So we know now that the volume of the hemisphere is this. Now we can easily find the capacity of the glass. Subtract the apparent capacity minus the volume of the cylinder. Volume of the hemisphere, sorry. So the actual capacity of the glass will be 196.25, which is the apparent capacity of the glass, minus the volume of the cylinder, which is 32.71, and that is going to give you 163.54 centimeter cube. So this is the actual capacity of the glass. The one thing you need to remember over here, the volume of the hemisphere, which is 2/3 pi r cube. And you need to know the volume of a cylinder, which is pi r squared h. And the rest is mere algebra and calculations. Great going. Let's try another problem. Let's try this problem. A solid toy is in the form of a hemisphere surrounded by a right circular cone. The height of the cone is 2 centimeters and the diameter of the base is 4 centimeters. Determine the volume of the toy. If a right circular cylinder circumscribes the toy, find the difference of the volumes of the cylinder and the toy. You can take pi to be 3.14. So let BPC be the hemisphere and ABC be the cone. So we already know that the height of the cone is 2 centimeters. BC, the diameter, is 4, so obviously BO, the radius of the hemisphere, as well as the radius of the base of the cone is going to be 2 centimeters. Now we can find the volume of the toy. The volume of the toy is going to be the volume of the hemisphere plus the volume of the cone. So what is the formula to find the volume of the hemisphere? Is 2/3 pi r cube. What is the formula to find the volume of a cone? It's 1/3 pi r squared h. So let's start the work. So volume of toy is volume of the hemisphere, which is 2/3 pi r cube, plus the volume of the cone, which is 1/3 pi r squared h. We know all the variables over here, so we can easily plug it in. So 2/3 times, as suggested in the question, 3.14 for pi, times, what is the radius of the hemisphere? 2. So this is going to be 2 cube plus 1/3 times 3.14 times the radius again is 2 squared, and the height of the cone is 2 centimeters. So we calculate this whole thing is going to be equal to 25.12 centimeter cube. You need to work out the calculation. The basic calculations what we have studied in our lower grades. So do work out the calculation and see whether you get this 25.12. And if you do it right, you will get it. So now we know what is the volume of the toy. So let the right circular cylinder EFGH circumscribe the given solid. So the radius of the cylinder is going to be the same as the radius of the hemisphere, isn't it? It's going to be 2. And the height of the cylinder is going to be the height of the cone plus OP. And how much is OP? Which is nothing but the radius of the hemisphere again, which is also 2. So the height of the cylinder is going to be h. So let's write down the height of the cylinder is going to be 4 and the radius of the cylinder is going to be 2. Now we can easily find out the volume of the required problem. It is the volume of the right circular cylinder minus the volume of the toy. So if we have to find the volume, so we are required to find the difference in the volumes. So let's find out the volume of the cylinder, and we have already found out the volume of the toy. Then we subtract them and we get the difference in the volumes. So the required volume is going to be the volume of the cylinder. What is the formula to find the volume of a cylinder? Pi r squared h. We can easily substitute over here pi, which is 3.14 times radius. The radius of the cylinder is 2 squared times the height of the cylinder is 4 minus the volume of the toy, which we already found out to be 25.12. Now we can easily calculate this, and that's going to be 25.12 centimeter cube. So hence the required difference of the two volumes is 25.12 centimeter squared. So first find the volume of the toy. How do you find the volume of the toy? It is the volume of the hemisphere plus the volume of the cone. Then find the volume of the cylinder, and then take the difference of that. You get the answer which is asked by the question. So great going. With this, we have completed the lesson on volumes of combination of solids. I look forward for you to work out more problems and also to watch my upcoming videos. Subscribe and share to this channel, Wisdom Outlined. Thank you very much.